So just as carbon can be involved in tons of different bonds and be bonded to a number of different atoms, there are select common functional groups that we'll encounter in biological molecules and that we'll encounter in this class in particular. Some of these, like I've said about other things, some of these will be reserved for your second biochemistry class, but a number of them will be found in this class, so for first exposure. So these different functional groups, your methyl, ethyl, phenyl groups, many of these should be familiar from your organic class, but maybe there are a couple that there's going to be kind of an increased significance for this class. For instance, a phosphoryl group. Okay, now a phosphoryl group is going to be relevant to what's known as a post-translational modification. That is the addition of a phosphate group onto an individual amino acid like serine or threonine. We'll get into that in the future. I would just take a moment to familiarize myself with these, make sure that I remember them and could identify them. In terms of, will you have a test question that asks you to inventory or identify these? Chances are slim, but this is kind of requisite information for this class. As I look through this, one that stands out to me right off the bat is this imine. That's something that you'll encounter in a metabolism class whenever you talk about mechanisms in that class. I would say that this class is analogous to your Organic 1 class in the sense that you're learning all of these foundational tools so that then you can apply them for looking at mechanisms and looking at different reactions. So this is a lot of learning, kind of learning the ropes in some respects. Now, we have an example molecule here, acetyl coenzyme A, or acetyl-CoA is what it's commonly known as. Now, this is a great molecule to use as an example to display all of these different, or a number of different functional groups. Acetyl coenzyme A has a thioester, 2 amidos, a phosphoanhydride hydroxyl group, an imidazole-like, an amino, and a phosphoryl group. So all of these different groups are worth knowing, and some of them we'll see more than others, but this is a molecule that's a high energy compound that ultimately will be used in entering the citric acid cycle or the Krebs cycle. Again, that would be in your biochemistry 2 class, but all of these different functional groups that are presented here, we're going to see, I believe all of them, we're going to see all of them this semester. For instance, that phosphoanhydride and that phosphoryl group, we're going to see those quite a bit this semester. Now, the ABCs of life, these 3 different groups, if you wanted to really sum up a biochemistry 1 class, it's these 3 things: your amino acids, your nucleic acids, and your lipids. Okay, those are your 3 heavy hitters when it comes to the simple monomeric subunits of life. Amino acids, those are your building blocks for proteins. Nucleic acids, those are your building blocks for DNA and RNA. Oh, sorry. Lipids, those are the building blocks. They're not used for forming a polymer, but those are the building blocks as a part of lipid bilayers and membranes. So these 3 big groups, those are some of the most important ones. And we're going to tackle these throughout the semester at different points. So exam number 1 will include nucleic acids. Exam number 2 will have amino acids, and I believe it's exam number 4 that has lipids. But like I've said, your content's available. If you want to review this at any point, you are more than welcome to. Okay, so the function of molecules strongly depends on their 3-dimensional structure. So structural organization. These terms should be familiar from your organic class. We've got stereoisomers. These have different physical properties. Geometric isomers have different physical and chemical properties. Cis versus trans. We'll see these in the context of cis fatty acids versus trans fats. Enantiomers, or mirror images, have identical physical properties except with regard to polarized light, and react identically with achiral reagents. Diastereomers have different physical and chemical properties. So we'll see some of these very quickly whenever we talk about carbohydrates. But just a little bit refresher for your organic, probably organic 1 class.